Kita disediakan banyak berbagai makanan khas Jepang. Kemudian dilanjut dengan saling tukar hadiah. Nah, ini dia bagian paling seru. Jadi salah satu teman kami, namanya Bena, dia membawa permen Super Zuper untuk sensei-sensei dan para astrep. Dan ini reaksinya.
Super super.
Oke.
Easy, isn't it?
Di hari ke-8, Jun Sensei membawa kami berwisata museum di Yamagata Prefecture Museum. Kegiatan di museum gak kalah seru. Di sana banyak banget pajangan yang berkaitan dengan kebudayaan Jepang, display spesimen herbarium, dan hewan-hewan endemik Jepang. Bahkan, di sana terdapat sejarah awal peradaban Jepang dari masa ke masa. Sehabis dari museum, Sensei memberikan waktu bebas untuk eksplor kota Yamagata. Ini adalah dinner terakhir kami. Hari terakhir, waktunya kami kembali menuju Bandara Narita untuk bersiap mengudara ke tanah air tercinta. Yang aku salut adalah Jun Sensei masih tetap setia menemani sampai bandara. Hari terakhir, waktunya kami kembali. Dan ya, itulah pengalaman kami kemarin di SSP 2024. Aku dan teman-teman ingin mengucapkan terima kasih banyak kepada pihak penyelenggara, kepada para dosen-dosen, sensei-sensei yang telah mengajarkan kami ilmu yang bermanfaat dan very insightful. Terutama untuk Jun Sensei, karena beliaulah yang telah menemani kami dari awal kedatangan hingga kepulangan. Aku juga ingin mengucapkan terima kasih banyak kepada para asisten, kemudian dosen pendamping Pak Bambang dan Bu Indah yang telah dengan sabarnya membimbing kami dan menemani proses dinamika pembelajaran di sana. Kami juga tak lupa ingin mengucapkan ribuan terima kasih banyak kepada pihak fakultas karena telah memberikan kami kesempatan yang besar tiada tara untuk pengalaman berkesan ini. Oke, itu aja untuk video kali ini. Aku Cancan dari Gen Kreatif, bebas berekspresi. Sampai jumpa. Kami juga tak lupa ingin mengucapkan ribuan terima kasih banyak kepada pihak fakultas karena telah memberikan kami kesempatan yang besar tiada tara untuk berkesan ini.
Universitas Gajah Mada, Faculty of Biology, was established on 19th September 1955 and located in Sleman, Yogyakarta, based on the consideration that Indonesia, as a country rich in natural resources, including flora and fauna, needs to develop biology as a strong basic science to support the development of other sciences related to biological systems. We have a vision of becoming a faculty with excelling study programs at the international level as a center for education, research, and community service in the field of biology, especially tropical biology, which is oriented towards the interests of the nation and based on Pancasila. Our quality has been guaranteed and proven for 2 decades. We receive accreditation by national and international institutions, and currently we are internationally accredited by ASIN for both undergraduate and master's programs. Since 2020, by QS World University, our faculty was ranked first in Indonesia in the field of biology. We have 3 study programs consisting of undergraduate and graduate. In bachelor education, we design a curriculum consisting of 8 semesters, where the 1st to 4th semesters focus on strengthening basic knowledge, and then students can start focusing on their interests by the 5th semester. The main interests in undergraduate studies consist of functional and developmental biology, environmental biology and biodiversity, and molecular biology and biotechnology. This study program consists of regular and international undergraduate program, where the IUP focuses more on gaining international exposure through the several international programs such as extracurriculars, internships, summer courses, exchange, MBKM, and double degree. Meanwhile, the graduate master's program consists of regular way and by-research way. The regular way provides a curriculum consisting of 4 semesters with a total of 42 credits. Meanwhile, the by-research way has 4 semesters with a total of 40 credits and focuses on research and publications. The study interests offered in master's degree consists of medical biology and forensics, industrial biology and bioengineering, biodiversity and biosystematics, functional and developmental biology, marine biology, systems and synthetic biology, and finally environmental and developmental biology. The doctoral program also consists of regular and research way. Our doctoral education consists of 6 semesters with a total of 46 credits, where the difference between these programs is the students by research program focuses on research and article publication. To support students' study, research, and non-academic activities, we provide various comfortable facilities with the latest and best equipment to help maximize student potential. To gain exposure at the international level, as well as gain new knowledge and perspectives, we provide various international programs. We hold research collaboration and joint publication, student and staff exchange, joint degree or dual degree with another university, visiting professors and guest lecturers, international summer courses, and international conferences. In total, we collaborate with 29 universities and research institutions from 12 countries. In conclusion, we are a biology faculty that focuses on developing biological sciences with various academic programs offered to students both at university and international level. In total, we collaborate with 29 universities and research institutions from 12 countries. To find out more about us, you can access our site at our social media. Faculty that focuses on developing biological sciences with various academic programs offered to students.
We explore the intricacies of evolutions and the diversity of living beings, delving into every layers that shapes the stories of life. The marvel of interactions between organisms and the environments forms biology as a philosophy of science that studies every detail of life. IUP Biology UGM has obtained international accreditation with professors graduated from developed countries, opening the door to the journey of science, understanding living beings and their evolution. Here, students are part of the scientific journey, becoming life-saving agents who not only observe, but protagonists who understand the story of life with the spirit of research and exploration. IUP Biology UGM has a global collaboration with more than 10 universities abroad. Located in Daerah Istimewa Yogyakarta, known as the City of Students with the title of having the best education in Indonesia. It is a place that serves as a meeting point for diverse students, from within the country to all corners of the world. IUP Biology UGM prepares students for global competition by offering opportunities to enhance both hard and soft skills, ensuring graduates are well equipped for their careers. Carve your story by delving into the secrets of life with IUP Biology UGM, where knowledge is not only learned but felt into the heartbeat. Carve your story by delving into the secrets of life with IUP Biology UGM.
Indonesia dianugerahi kekayaan hayati yang luar biasa. Dari hutan tropis yang lebat hingga terumbu karang penuh warna, setiap spesies memainkan peran penting dalam menjaga keseimbangan bumi. Yogyakarta, dengan beragam ekosistem dari hutan pegunungan hingga kawasan pesisir, merupakan tempat ideal untuk memahami dan melestarikan kekayaan biodiversitas Indonesia. Berlokasi di Kota Pelajar Yogyakarta, Fakultas Biologi Universitas Gadjah Mada telah lama dikenal sebagai pusat unggulan pendidikan dan riset di bidang biologi dan konservasi. Didukung oleh tenaga pengajar berpengalaman dan fasilitas modern, kami berkomitmen mencetak ahli yang tidak hanya kompeten, tetapi juga peduli terhadap pelestarian alam. Program Studi Profesi Kurator Keanekaragaman Hayati PKKH hadir sebagai program pionir pertama di Indonesia dan Asia. Program ini dirancang khusus untuk menghasilkan tenaga profesional yang ahli dalam mendokumentasikan, melindungi, mengelola, serta melakukan kurasi keanekaragaman hayati secara ilmiah dan terstruktur. Dalam program ini, mahasiswa akan menggabungkan teori mendalam dengan praktik intensif. Mereka secara langsung terlibat dalam eksplorasi alam, mengidentifikasi spesies langka, serta mengelola koleksi hayati tumbuhan, hewan, dan mikroorganisme di lapangan maupun di laboratorium. Program PKKH ditempuh dalam waktu 2 semester atau 1 tahun dalam 36 SKS dengan komposisi 64% kegiatan praktik lapangan dan laboratorium serta 36% perkuliahan di kelas. Mahasiswa akan mengikuti rangkaian mata kuliah unggulan seperti sistematika dan diversitas biotik, manajemen dan perawatan koleksi, perencanaan kurasi, analisis dan validasi koleksi hayati, pendataan koleksi, manajemen sumber daya hayati, dan analisis data biologi. Kurikulum ini juga diperkaya dengan materi kewirausahaan berbasis bioprospeksi biodiversitas. Mahasiswa dibimbing oleh dosen-dosen bersertifikasi internasional serta pakar dari BRIN, WWF, dan Universitas Mitra Luar Negeri. Dukungan fasilitas modern berupa laboratorium genomik canggih, ruang belajar nyaman, serta Museum Biologi UGM yang memiliki koleksi spesimen berstandar internasional akan semakin memperkuat kompetensi mahasiswa. Setelah lulus, Anda akan siap menjadi kurator profesional dengan berbagai pilihan karir di lembaga konservasi, museum, kebun raya, taman nasional, laboratorium forensik, industri farmasi, pest control, maupun instansi pemerintah. Mari bergabung bersama kami di program studi Profesi Kurator Keanekaragaman Hayati Fakultas Biologi Universitas Gadjah Mada. Jadilah bagian dari pelestari biodiversitas Indonesia demi kehidupan masa depan yang lebih baik. Karena keanekaragaman hayati adalah warisan kita, mari kita lindungi bersama. Fakultas Biologi Universitas Gadjah Mada. Jadilah bagian dari pelestari biodiversitas Indonesia demi kehidupan masa depan yang lebih baik. Karena keanekaragaman hayati adalah warisan kita, mari kita lindungi bersama. Fakultas Biologi Universitas Gadjah Mada. Jadilah bagian dari pelestari biodiversitas.
Welcome to the 7th International Summer Course on Tropical Biodiversity and Sustainable Development. Embark on a global journey into the heart of diverse ecosystem. Brilliant minds from around the world converge, sharing insight on Southeast Asian tropical biology ecosystem. This isn't your average classroom. Get ready for hands-on learning that immerses you in the intricate web of tropical biodiversity.
The Faculty of Biology at Gadjah Mada University, as a member of the Asian Biodiversity and Conservation Network, commits targeting student and young professionals as agent of a change to sustainability preserve tropical biological ecosystems. Therefore, we have been organizing an annual summer lecture series since 2018 with the term Summer Course on Tropical Biodiversity and Sustainable Development. So, join us in preserving tropical ecosystem sustainably. dive into unforgettable adventure with our international summer course on tropical biodiversity and sustainable development. Experience the perfect blend of online learning and thrilling on-site exploration. From discovering Japanese culture to exploring ancient temples and coastal wonders. Our field trips promise an immersive journey. Engage in insect sampling, bird observations, and discover the secret of community environment in coffee, milk, and honey production. Join us for an enriching experience like never before.
The Asian Biodiversity and Conservation Networks invite you to be part of the solution. This course enhances your understanding of sustainable development, equipping you to contribute Southeast Asia's biodiversity conservation. Ready to make difference? Seize the opportunity to join global movement towards sustainable tropical biology development. Register now for the 7th International Summer Course on Tropical Biodiversity and Sustainable Development. Unleash your potential, explore biodiversity, and create lasting memories. The adventure of a lifetime awaits you. Seize the opportunity to join global movement towards sustainable tropical biology development. Register now for the 7th International Summer Course on Tropical Biodiversity and Sustainable Development. Unleash your potential, explore biodiversity, and create lasting memories. The adventure of a lifetime awaits you.
So that's why it's a really good program for all the students who will be our future leaders, learn each other how we can work together to make our nation better.
My name's Maya. Today's just been great, honestly. We saw some squirrels trying to get the bananas off the monkeys. That was pretty funny to watch. Everything they've really said we've seen, it's been really cool.
This guest lecture. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for joining today's guest lecture, both on site on Auditorium Biologi Tropika, as well as joining us online on Zoom. We have another attendees on Zoom. First of all, I would like to greet our guest lecture today, Prof. Jin Hee-han and Dr. Chun Ho-jung from University, Kangwon National University, South Korea. Welcome to UGM. I believe this is your first time in UGM. We have okay, so on Zoom. Please enjoy your visit in our university. And the Honorable Dean of Faculty of Biology, UGM, Prof. Dr. Budi Setiadi, and our Vice Dean of Research, Community Service, Collaboration, and Alumni Affairs, Luciano, and college that are here with us today, and our respected lecture students of Faculty of Biology and outside of Faculty of Biology that joining us on today's lecture. First of all, let's express our gratitude to the Almighty God so we can gather here in a good health to today's guest lecture with the theme Bridging Biological Science and Translational Biomedical Research in Vector-Borne and Zoonotic Disease. Okay, before we go to the main session of the guest lecture, I'd like to invite Prof. Budi Setiadi Daryono to the front to deliver his welcoming remarks and to open this guest lecture as well. Please, Prof. Budi, the floor is yours.
Thank you, Anissa. Good morning, everyone. The Honorable Professor Jin Hee-han and also Dr. Jun Hozong. Yeah, I'm sorry, with my maybe I have a mistake with your name. Also, my friends, my colleague, Professor Iko is the Vice Dean for Research, Community Services, and also Collaboration and Alumni. It's a very busy, so many many fields. And also we have from International Office or our faculty, Dr. Martin Nuhamunada and also Dr. Indah. Yes, all of them will be carry on for the collaboration, yeah, international collaboration. And also our guests from BRIN, National Institute Research. There's so many here. So many. How many? Maybe six, seven. Yeah. Thank you so much. Because they are come from a little bit apart from Yogyakarta. It will takes maybe 2 hours by cars, yeah, from Salatiga. But now Brin is not only in location, yeah. You can what you call walk from everywhere. We now walk from everywhere. And also all of the students, maybe some of students from our faculty, undergraduate, also master, yes, also. And we have more than 60 by online, 60 participants. Hello, good morning, everyone. So yeah, waiting for the guest lecture. First of all, on behalf of the faculty, as a dean, I would like to express and welcome Professor Jean and Dr. June to our faculty and also to Yogyakarta. Mbak Anissa already mentioned that maybe this is the first time for you to come to Yogyakarta. As you know, Yogyakarta is not only is the culture city, because this is the old city. This was established in 15th century, and the kingdoms moved to the new one in 1753, around there, 1753. So maybe you will visit later on to see the kingdom village, yeah, of Sultan of Yogyakarta. So Yogyakarta is also the education city. So we have more than 100 university here. Four is national university, including UGM. UGM is the oldest university state by state in Indonesia. So we established in 1949. So it's 60 years old. Um, if you come to Yogyakarta, maybe you will soon visit the two what we call World Heritage. Yeah, Borobudur in the west part of Yogyakarta. So maybe you can reach in 1.5 hours by cars. And Prambanan is more closer. In the eastern part, yeah, it's maybe 30 or 45 minutes by car. So I do hope and I suggest during your visit in Indonesia or in Yogyakarta, you should visit the Buddhist temple, the biggest Buddhist temple in the world, Borobudur, and also the Hindus' biggest temple, yes, Prambanan. As I already mentioned, this UGM also has more than 60,000 students. So this is a big number of, because you know the Indonesian population is reached to 280 million. So that's why our university also has the big capacity for students. And we have 18 faculties. 18 faculties and 2 schools, the graduate school and also the vocational school. So among 18 faculties, the faculty of biology always number one. Why? Because in alphabetical Indonesian language, B is number one. So we don't have any faculty by A in the front, because agriculture in Indonesia is pertanian, P. Yeah. So that's why you are in the right time. You visit biology because we are the first faculty using Indonesian alphabet. Sorry, this is just a joke. Then we already established 70 years ago, 19 September 1955. So you can see the dean. So now maybe I'm the 13 or 12, I forget. Yeah. So at the beginning, like you, we come from faculty of medicine. So our first dean, he is a doctor, medical doctor. Yeah. And then we combine with agricultures and forestry. So biology is come from botany and zoology. And we have one department, tropical biodiversity. So this room, this auditorium, we call it the auditorium for tropical biology. So the name of this room. And we are very happy because today, this is very important for our faculty. You will give the guest lectures. Yeah? And we work together with brains for a long time. Also in the exploration of Ricus vectora, or maybe in English, Ricus vectora is all research in vector-borne and zoonotic disease. So we work together. Yeah. So again, we are very happy to have you, and we do hope Paiko later on will maybe explain. We do hope maybe you also will open, or you can conduct like winter course for our undergraduate program to visit Korea. So they love winter. So we have program with Yamagata University start from 2017 to date. They have the course for 1 week or 10 days. So we will send our student, please, maybe in the workshop or maybe training in vector-borne and zoonotic disease along with BRIN. So we will send our student, both undergraduates as well as graduate student. Pak Eko, Pak Martin, and Bu Wenda, I think this is very important, yeah, if they have training or workshop for our student in the near future, please. Or maybe if you don't mind, you also have many beautiful view and also flower. Maybe in the spring also, okay. Because some Indonesian, maybe not Pak Eko, Professor Eko is very strong in winter. Not like me, I'm very weak in winter. Prof Eko very strong in winter. But some Indonesian like so much your countries, both for K-pop, K-pop, as well as your science and technology, your culture, and also your natures. Yeah, like in winter and in the spring, very beautiful. Without further ado, I would like to open officially the guest lecture on the title Bridging Biological Science and Translational Biomedical Research in Vector-Borne and Zoonotic Disease, delivered by Professor Jin Hee Han and Dr. Jun Ho Jung from Kangwon National University. Enjoy your guest lecture, and also I do hope this will be fruitful for all the participants. Thank you so much.
Okay. Thank you so much, Prof. Budi, for the welcome remarks. We kindly ask you to stay on the stage, and we invite Prof. Jean and Dr. Jun to come to the stage to receive a little present from our faculty and take a picture first together. Please.
These are our prediction.
If all the participants could go to the stage to take a picture together, and we kindly ask for the participant that joining us online Zoom to come to joining us to open the camera, and we can take the picture from the Zoom as well. Mungkin ke sisi yang sini masih kosong. Okay. Okay. Ready? 1, 2, 3. Okay. 1, 2, 3. Okay. And for the Zoom as well, we would take a screenshot. 1, 2, 3. Okay. Okay. Thank you. Okay, thank you so much. So now we're moving to the main session for today's guest lecture, featuring our lecturer from Kangwon University. And for this session, I'm pleased to introduce our moderator today, Pak Martin Muhammad, PhD. He is the head of the Office of International Affairs, Faculty of Biology, as well as lecturer from Laboratory of Biotechnology, Faculty of Biology. Please, Pak Martin, the floor is yours.
Okay, thank you, Anissa, and thank you also, Pak Budi, Pak Eko, for opening the events. So glad to have all of you here this morning. My name is Martin, and I will be helping you to listen to our amazing guest lecture today for in the next hour. So today we have two distinguished speakers, Professor Jin Hihan and Dr. Jun Ho Jong from Kangwon National University. And as I understand, both of you already have collaboration with Indonesia, especially with BRIN and UNDIP, if I'm not wrong. So we're eager to listen to your story and your experience, especially in bridging biological sciences and translational biomedical research in vector-borne and zoonotic disease. And just for your information, also in our faculty, we have the Laboratory of Entomology, and they do have quite a lot of research also on mosquito-related vector-borne disease. And I think joining online, there are some lectures from the lab, so we might have a nice discussion later. But without further ado, I would like to invite both of you to come to the stage and give the presentation. So, Prof. Jin and Dr. Jin, time is yours. Yeah. I need to first. Okay, while we are waiting to set up the presentation, I would like to ask our friends from BRIN, how long have you been collaborating with our friends?
Actually, this we started to know both of Prof. Jin Han and Dr. Jin Ho Jong since 2023. Almost like
Okay.
and starting like
Yes,
with
right.
locality.
Yeah.
Yes.
So it's been three years already.
Your corporation, I think this we just want to initiate.
Okay. So I'm hoping that we will have a really nice discussion afterwards.
Here, organization, right?
But yeah, I think it's not on the microphone. But I hope that we can also collaborate because we also have a lot of collaboration also with our friend from BRIN and other faculty and also students. This is your opportunity to ask questions, and maybe if you're interested, you might have a chance to visit their lab in Korea. So okay, so I think it's ready. So I'll give the floor to you. Right. Okay.
Nice to meet you, everyone. Oh, yeah, nice to meet you. Actually, it's supposed to be yesterday. We have to be in the yeah, but last night we missed that flight. At the Jakarta have a heavy traffic jam. So yeah, so just today morning you'll have to hear. So I'm very sorry to late 30 minutes probably. I'm really sorry. So this is a very early stage to relationship with the UGM. So today I'm thinking about which topic is better to present to you guys. So I'm just choose that my topic is what I do now in my lab. So I'm working in the medical school in Kangwon National University, South Korea. My faculty is Department Tropical Medicine, the Department of Tropical Medicine. So previously our department name is Parasitology, Department of Parasitology actually. But based on the current trend, we changed the name to the Tropical Medicine. So we can cover more than the parasite actually. So today I would like to introduce about my work in my lab. Actually, I'm a microbiologist. So somehow maybe some talk is difficult, but I'm trying to explain what I'm doing now. So today's title is the life and receptor interactions underlying human adaptation of non-rabinaria malaria parasite. Yes, I'm studying about the malaria based on molecular biology. Yeah, let's begin. Before I start, it's better to introduce about the Korean malaria situation. So many people think Korea is already developed country and there is no malaria anymore, but that's not true. We have a lot of malaria cases. Korea is very special country because we still divided by the North Korea and South Korea. So this red color, this line, black color line is a borderline with the North and South Korea. And in this part is we call the DMZ, that means demilitarized zone. So nobody can enter in that area. That means nobody can control the mosquito in here. But the North Korea have every year have a malaria patient around here, around the DMZ, and South Korea too. Around the DMZ have malaria cases annually. It's very strange because in Korea has a winter season. In Korea, winter is very cold, super cold. It's below 10 degrees, something like this. So mosquito could not survive at the winter season. That means in the winter season cannot transmit the malaria, but we still have every spring season appear the patient. Even still don't know exactly why Korea every spring season appear the patient because at the winter season stop the transmission. So in Korean government also want to solve that question, but still don't know actually. Annually, the Korea have the 7 to 600 patients occurred. Actually, this number of patients is more higher than the Vietnam. That means tropical area. So it quite a lot actually. Of course, Korean government also wants to control these malaria cases and eliminate the ones, but somehow it has difficulties. One of that is mosquito control in this DMG line, and I don't know, other factors. Anyway, it's very difficult. So actually, we don't know exactly the North Korea, the malaria situation, but we just estimate 10 times higher than South Korea. Based on WHO, they also provide some malaria drug to the North Korea, but always 10 times higher number of drug supply just support to the North Korea. That means probably 10 times higher patient in the North Korea. So it has always argued with the North Korea and South Korea, they fight each other by government. The first case of malaria, where it came from? The North Korea said from South Korea. South Korea said from the North Korea, something like this. But we don't know actually where it came from. And yeah, Even this year, just even winter season in this year, in Korea has two cases of the malaria from imported cases. Because Korea also has imported cases from the other country. And it's very interesting. The Korea epidemiology of malaria is based on the gender. The male is a majority, is the male, the 517 in 2025. And female is only 84 patient. So male is the major. Yeah. And based on the age, 20 to 29, the young men get the malaria a lot. And because many patients are called in the DMZ area around here, this borderline. So they are is at the army. They're in the army service. So in the army, military service army, they get a lot of malaria patients. But Korean men, you know that we have to go to join the military service. That is the duty of Korean men. So many young guys always get the malaria in Korea. So this is a malaria situation in Korea. Today topic is the non-human primate malaria can transmit to the human or not. That is my major topic. So actually, in our school, I teach my students, the medical school student, as only 5 species of plasmodium can infect a human. That is human malaria. That includes Plasmodium vivax, which is in Korea only have this Plasmodium vivax. And Plasmodium knowledii, actually this is genetic malaria, partially discovered in human in 2004. Quite short history, right? And major country of this knowledge is nowadays we know that Malaysia. And even the Indonesia also have a pinology cases. Malaria and ovale also caught in the human, and P-falciparum also in called human. But genetically they are quite divided by the falciparum-like parasite in here and vivax-like parasite in this line. So we divide that by clade. The falciparum-like parasite is laminaria clade, and vivax-like parasite we call non-laminaria clade. So much focus on the non-laminaria clade parasite because in Korea still have vivax cases. Okay. So previously when I was in the New Zealand, actually I work on the Psinomorgi that is closely related to the vivax by genetically. And this is actually the monkey malaria parasite, and 2014 postally described in the human. It can infect the human. So this video, when I was in the postdoctor in 2019, I just take a video of how the parasite invade to the red blood cells. So can you play this video? Can you play the video? Yes, it played. Yeah, so the small down there is a merozoite, each side of them. And this circle is the red blood cell. So if you have an infection of the plasmodium in the bloodstream, it happens like this. So this merozoite trying to invade to the red blood cells. Yeah, you are called attachment, right? And but to focus on in here, this merozoite, yeah, also called attachment, and they invade. The host cell change the shape to the echinocyte, and they will recover. So this is a process of plasmodium parasite invasion. But this process finished within 2 minutes, right? Within 2 minutes is a real time. That means this process is very quick process. So all of the malaria vaccine will have to block this invasion process. The means of antibody or other small molecules have to work in within these 2 minutes. Otherwise, it cannot be work. Okay, so my research topic and question how this merozoite can invade the host cell, how they recognize the host cell at a molecular level. So there is a lot of protein they expressed by the merozoite. We know that around 6,000 to 8,000 proteins expressed in the merozoite. Among them, some protein is very important to the invasion. So, one, for example, is a PBP, we call the dumping binding protein. This protein is most essential protein to invade the host cell. They interact with human RBC receptor, we call DARC, Dopey antigen receptor for chemokine, that is DARC. So if they block this, if we block this interaction, the merozoite totally cannot invade. So many researchers are trying to develop the vaccine based on the PBDBP, but has a problem because PBDBP in the nature has a lot of variant. All the malaria vaccine has same problem. In the nature have a so high variant. That's why the vaccine, the efficiency is very low, cannot block. And also in the other species like Pinolazi, actually the genetic malaria, now a major malaria parasite in Malaysia. Pinolazi also has a similar protein, PKDBP, we call that, PKDBP alpha. And Psinomyzide, also genetic malaria, they also have a PCY-DBP1, but they have another copy, PCY-DBP2 also. And in case of PBEBP, this erythrocyte binding protein, they also have Psinomyzide also have a PCY-EBP. We call homologue. This is homologue. And the RBP line, this reticulocyte binding protein 1A, 1B, a lot. There is a lot. All of these ligand interact with some receptor on the red blood cells. They have to invade the merozoite into the red blood cells. So interestingly, PVRBP, Vivax and Psinomyzide have a very similar protein. They share each other. But PK has MVP some little different proteins. So based on that, phylogenetically, Vivax and Cytomyzide is very close. It's just like a sibling each other. Pinolazi is little far from the Vivax. But anyway, all of these proteins are very important to the merozoite invasion to the red blood cells. So on my research, I'm focused on this PVDBP and PKDBP and PCY-DBP1, how they interact with the DARC, especially human DARC and natural host monkey DARC. So more introduction of the PVDBP and DARC interaction is like this. So this Vivax, Plasmodium vivax merozoite, when they invade to the reticulocyte, it has interacted each other like this. The upper part is PVDBP and bottom part is DRC. They make a homodimer. And finally, they form a tetramer bond. They just interact like this. They recognize each other like this. And if they recognize correctly, they can invade. If we block here, this interaction, they cannot invade. In DRC part, most important residue we call FY6, this red color. Each yellow color that is amino acid. So this red color is FY6 domain. If we use antibody to interrupt this red part, the metazoid cannot be invaded. So this FY6 domain is most important part for the PVDVP binding. Okay. So that means like this. This is a red color DLC is FY6 domain, so we can block by 2C3 monoclonal antibody. If we use 2C3 monoclonal antibody, they cannot interact with each other, they cannot bind each other, and the myeloid cannot invade. So this is literally very nice vaccine target actually, but in the plant side, it cannot be worked. Okay, so and in this graph show the FY6 domain. If we use that antibody, it cannot be invaded. 0.1% like this, and this is by the microscope image. So I made a plan. The model is like that. If we can measure the human DRC and monkey DRC and PQDBP, PBDBP, and PCYDBP, their interaction strengths, we can know where is the most important residue, human adaptation. Okay, just for like this. The P virus can invade a human. The major host is a human, right? This is me. No copyright. I can use my picture, right? I don't know who is him, this monkey, I don't know. Or maybe he has no copyright, right? Anyway, P virus, the major host is a human, right? Rather than monkey. And P. knowledzi, nowadays in Malaysia, there has a almost equal invasion rate. That means they already starting to adapt to human. So P. knowledzi, the adaptability is equal to monkey and human. And P. cynomolgi is more adapted to the monkey because nowadays in human cases, very, very low, maybe accidentally invade the human. So based on this DMP and DRC measurement, the binding strength measurement, we can estimate this situation now. So this is a schematic workflow. So we use the hex cell, this mammalian cell line, to express the protein. So in the lab, we express protein, recombinant protein for PKDBP, PVDBP, and PCYDBP1, and monkey DRC and human DRC. And by experimentally, we can measure the binding strengths, like using the ELISA or even precipitation method, or we call the BLI method like this. This is just an experimental tool like this. Okay, for the results, if we compare the amino acid sequence of the PC, PV, PKWP, they all conserve cysteine. It means these proteins, the structure will be very similar. That means they have a very similar functions too. So we compare all the sequence of the DVPs. The molecular means that they just the same. All these four sequence same. The similarity strengths I just represent by the color bar. And in the DLC, most important part is this FY6 domain. But in the human, have two types of DRC in the nature. We call it FYA and FYB. Just different in the amino acid residue 42. So FYA show the glycine in this part, and FYB is changed to the D. In the nature, the monkey, actually this monkey is Macaca fasciscularis, pigtail monkey. The monkey showed the deletion, one deletion of amino acid position 23 in glutamic acid. It has deletion. So it will affect the TDP binding activity because they located in the FY6 domain, most important domain, right? So we try to measure these interactions. So the figure A, which this is show the schematic structure of the DBPs. Within the DBP is R2. R2 domain is most important for the DRC binding. So we just choose this R2 domain for expression by the protein. So panel B, we can see how they were expressed. We confirmed by SDS page method. Based on this protein size, we can estimate how they were expressed. So PVR2 has a one band that means expressed well, and with alpha also expressed well, and other proteins are all expressed very well. And then this expressed protein, we're trying to how to say make the interaction with the blood cell directly. So we can confirm this protein is correctly folded one. That means this expressed protein is the same as metabolic protein one. That we have to confirm right there. So at the moment we use the monkey blood and human blood. Monkey blood from the macaque fascicularius. So the results show that in panel B, the PVP, the binding activity is around 20%. That means almost 20% of RBC bind with the DLCs. PVP and PCDVP is more stronger than PVDVP, but PCDVP2 is much stronger. But after we confirm that PCYDVP2 is not interact with the DLC, so that means PCYDVP2 should have a different receptor, not DLC. And PCYDVP1 interact with the DLC, but in the monkey blood, stronger than human. PVDVP binding activity. In the human blood, we divide to the normocyte and reticulocyte because iBox parasite, they prefer to invade, only can invade to the reticulocyte. That's why we filtrated to the reticulocyte and normocyte. Normocyte is an old red blood cell, and reticulocyte is a young stage red blood cells. So based on the results, PVDVP, internally, PVDVP, they much stronger, interact much well in the reticulocytes, and PCDVP1, also reticulocyte interact very well, and PCDVP2 also. But in the human blood, the PVDVP2, the interaction, the binding activity is stronger than the PCYDVP1. That means the PVDVP, the biomax malaria, still prefer to interact with the human DRC or human red blood cells in here. And also we can conclude that this expressed protein, because we express in the outside, we express by another cell. So in this experiment, we can confirm our expressed protein, the functions is similar as a metabolic protein, native protein form. Okay. After that, we confirmed using precipitation method. In panel A, you have this E lane have a double band. That means they have an interaction. If you have a single lane, there is no interaction. So PVDVP with monkey. This is monkey DRC, but it has a deletion in 23 glutamic acid. There is no interactions, and just monkey DRC also no interaction, but human DRC has a double band. That means have an interaction each other. And PCDVP1 have a weak interaction with if they have a deletion in 23 glutamic acid. But in here, just normal monkey DRC has a strong interaction, and human DRC also has a strong interaction. But PCDVP2 has totally no interactions. So PCDBP2 have a very high binding activity with the monkey blood and human blood, but they not interact with the DRC. That means they have a different receptor. But still, we don't know which receptor they interact each other. And PKDBP, they interact all of this, the monkey DRC, human DRC, whatever, they interact each other. And the last CD43 plus 4, this is negative control. It should not interact each other like this. And we move to the DP and DRC interaction by the BLI. So this is quite complex graph, right? Each panel, it indicates the binding, real-time binding the strengths. So PVDBP with the human DRC, they interact slowly and disattach slowly like this. So binding affinity, we can calculate based on this graph by the KD value. So KD means their binding strengths. So lower number value is indicate more strong binding. Okay. So the PVDBP with the human DS KD value is 7.7 or more. And PKDBP alpha with the human DRC is 20 nanomolar. That means the PVDBP much prefer to bind with the human DRC. They are more strong binding, have a more strong binding. That means P box DBP is much adapt to the human rather than the human DRC rather than PKDBP. And PCY-DBP1 show the key value is 9.8, with the human DRC is the binding affinity is less than this PVDBP. That means compared with the PV and PCY-DBP1, the PVDBP has a more strong binding with the human DRC. With the monkey DRC, the PVDBP with the monkey DRC interaction 18.7 nanomolar. That means compared to the human DRC, they have a low binding affinity, right? But they can interact with the PVDBP also can interact with the monkey DRC, but that strength is lower than the human DRC. And the PCY-DBP1, KD value is 3.3. That means much strong binding have in the monkey DRC rather than human DRC. Because human DRC is a 9.8 nanomolar, the 3 times higher binding affinity it has. And if we have a deletion in FR6 domain, so slightly decrease the binding affinity, and even the PKDBP alpha also, and PCY-DBP alpha also, but still they have a strong binding affinity rather than the human DRC, the interactions. So based on that, we can estimate the PVDBP, they prefer to interact with the human DRC, most lowest value we occur. And PKDBP, actually in monkey DRC interaction is looks stronger, but actually almost similar. They are 20, 14, 22 like this. But this is this binding strength is less than PVDBP. PCDBP, they have a low value in the monkey DRC. That means the PCDBP still, they adapt to the monkey rather than human. Okay. Important thing is also this graph pattern. PVDBP, the interaction is they increase the value slowly and decrease value also slowly. But PKDBP alpha, they increase quickly and static and decrease quickly like this. Because the PVDBP, they make a homodimer and finally they interact by tetramer, as I show you the figures, right? But PKDBP has a different pattern. Only one DBP and one DRC interact with each other. They may not make a dimer form. That's why the binding pattern increase quickly and decrease quickly. So we still don't know PCDBP, how they interact with the human DRC or monkey DRC. Based on the graph pattern, they also very slowly increase and slowly decrease. That means PCDBP1 also interact by the tetramer form, like a PVDBP. So we can estimate that. So based on this result, what we can interpret? So we can know the amino acid sequence of P5 box in here, and P-monoxide and P-cyanomoxide 1. And based on this result, P-biobox-DVP to the human. PKDVP almost equal. This is the VP to the monkey. So if we compare important residue, amino acid residue, we can estimate which amino acid is most important to the other to the human. Means in the future, we can targeting the residue to protect the nitrate invasion. We don't need to think about the whole domain, just the residue is most important. Okay, so in position 277 in amino acid I in PVDVP, but in PKDVP they change it to the M, and PCYDVP also change it to the M. That means this M, and also this 355, this part A to E. All of this orange color residue is important to the monkey adaptation with human. But here, PVDVP is allele, and PKDVP also allele. But this only PCYDVP have isoleucine. Amino acid. That means this is critical residue for the monkey adaptation. This is critical because PKDVP historically actually never know, but in hypothesis historically PKDVP also in this part should be isolation like a PCDVP, but nowadays change when we adapt to the human to valine. So the binding is similar with the PKDVP like this. So we adapt the human like this way. Okay. The yellow color is specific to the PKDVP. So specific to in PKDVP, they make the protein infection, make a tetramer. So if this residue change to Y and change it to K, they can make tetramer form. So like this, we can estimate which amino acid involved, which function, and which amino acid we can target in the vaccine development, or also we can use for the small molecule like this to block the nitrate invasion. So you can see also similar it's just which residue with which residue interact each other, they show like this. Okay, so in the summary of this finding is that based on the natural host selection criteria preference, the hypothesis and result is followed like this. The PVDVP are to show higher binding affinity in human DRC, right? And PCDVP1 are to show the higher affinity in the monkey, not the human. And PKD show the similar affinity in human and monkey DRC. So that is well represented in nature situation, in natural situation, because people biogas, the major host is a human, right? And P-cyanomoxide, major host is monkey, Macrocophasis curaris. And P5 is the other to the human, so must equal adaptation in occurred. So keep the based on the DVP and DRC interaction in monkey or human, we can exactly get the same result, how they, based on the binding strength, how they adapt to human, and which residue is very important for the adaptation of the human. Yeah. So that means it is one based on the interaction affinity measurement, we can figure out critical residues to make a difference in the host selectivity. So if this is the key to change this solution to valine, maybe they more adapt to the human. So we have to targeting this residue to protect the PCDVP adaptation to the human. Okay. Another result is the PCDVP2 show very high binding activity with the monkey RBC, but we don't know the exact receptor. Anyway, they not interact with the DRC, but it should be very important receptor for monkey invasion, monkey blood cell invasions. Okay. So ongoing project is that actually there is a lot of genetic malaria, not only cynomolgi, and natural host has also a lot. Even the human should be the natural host of the those non-malaria parasite plate. And this one is chimpanzee also, quite similar with the human, only 0.1% that no, almost 1% different with the human genome with the chimpanzee. So they can invade. And this is gorilla and other monkeys. It's quite similar, only 4% different with the human genomes. So just plasmodium species should and could adapt to the just natural host. So based on the DOEP and DRC interaction strength study, all of these species, we can exactly point out which residue is important to the human adaptation. And in the future, we can just block that interaction in using the residue. So that is our plan and ongoing project is that. Yeah, this work actually will collaborate lots of researchers from University of Ottawa in New Zealand, where I was doing the postdoctoral fellow in here, and US in Singapore, National University of Singapore, and A-Star also in the Singapore, and we have in Korea have a Pasteur Institute. Yeah, in our university members is here, and this is our building, beautiful sky. It's not like a Jakarta. Quite clear sky is here. Yeah. Okay. So this is our main building. Okay. Thank you so much.
Thank you, Professor. I think we still have one more speakers, right? And I think I'll try to summarize, even though it's not my expertise. So I think on top of the amazing findings, I think you study about host switching of malaria or plasmodium between human and macaque. And I think what I find amazing is that you build a model system in the lab so you can have the ability to look into the mechanism in details. And this is really relevant to also the topic of One Health and our challenge right now in the changing climate. So let's give applause to our speakers. And I would like to invite our next speaker, Dr. Jun, to give the talk. I think, can you try? Or okay.
Anyway. Hello, nice to meet you.
Okay.
Selamat pagi. Selamat pagi. Okay, today I want to talk about the mosquito-based fly virus monitoring in Korea. Before, the Professor Han, he talking about the deep molecular biology, and I think it's something understanding hardly to undergraduate student. And then in my case, have some easily to and something more approach to the Gajah University undergraduate students, the issues. Okay. Yeah, firstly is background. I don't know, is in Indonesia cases, the climate change is how much is important. But in yeah, but in Korea, they have a lot of the issues in climate change because we have a 4 season, but in Korea now have a 2 season only because winter and summer. Yeah. Because just a few days spring and just a few days autumn. Yeah. Climate change has the big issues in all the world, but in mosquito have also very important issues because rising temperature increase, the mosquito adult is also and survival increase. And in case of the data, in Korea, first annual appearance of the Curex Tritonicus is the JEV, the primary vector in Korea. The before the 1980s, after June, they have a first appearance, but after climate change, we first annual the appearance is Curex Tritanicus. They have the middle of April. So the earlier seasonal emergency, they have a long transmission season, their background. Okay, after one. The increased human mobility and important increased infection disease because in Korea we don't have any Zika virus or dengue virus and other issues, but the lots of the people they have a move me also, and then during the COVID situation they have the traveler the decreased, but after that they increased. So total import case has the increase also, and they have lots of the dengue fever and malaria and chikungunya fevers. Actually, last year I got the dengue fever in Cambodia and come to Korea, and then I also have imported cases. And then globalizing emerging viral and vector-borne disease, because we don't know the which kind of disease and which kind of fly virus or something most vector-borne disease is increased. Sometimes just 10 years ago, the Zika virus outbreak in the Brazil. So we don't know many kind of the national virus or something globally increase the flaviviruses also. And so also in Korea, we have a nationalized mosquito survey program. So sorry, this one is Korean word, Korean alphabet, but this let's part here has some mosquito collection places. So 105 site in 48 local area, and then 54 site in 18 province, they have a mosquito collection. And then we just make out data and make warning system. There is the object. So we can make as like this one. Mosquito-based survey is early detection, emerging disease in Korea. The mosquito collection to species identification, pathogen screening, and risk assessment, and then early prevention to the civil. That is our object. So how the method? In my case, I collect the mosquito in the central part, capital part of Korea, and using the 7 mosquito trap. Do you know black light trap? And then I think you guys know the black light trap, but you guys don't know the BG trap, BG sentinel trap. Some undergraduate students don't know that, but yeah. So I use 7 trap and collection twice per month each site, and sample period is March to October. So blend light, I use blend light trap and BG sentinel trap. Urban have two blend light trap and one BG trap, and airport area also two BL trap and one BG trap, and the cattle shed also. So attraction use the dry ice. So when I make the trap, there we put the dry ice. And BG lure also use, this is BG lure. So the travelers set before the sunset and collected at the sunrise. That's one night collection. So I moved to mosquito collection and using dry ice preserve to viral RNA. Also, how to homogenize the mosquito? I use this 10 mosquitoes below. I use the 300 microliters PBS and to make a pool. Firstly, species identification and then pool the sample. Homogenize the issues condition also like this. And then private screening by real-time and RT-PCR. Because the cyber-based real-time PCR, you know that the group-specific primers, I make that. And we use the amplification cover and the melting curve analysis. And based on this method, this primer is this paper. Okay, I skip the how to the principle of the real-time PCR and melting cover. So concept. What is the concept for the primer? Fly virus is all most fly virus they have the similar. Dengue virus, Zika, Western Nile, JV, yellow fever, almost similar. So, and then conserved lesion is the NS5. There has the non-structured protein, so they have the lots of the conserved lesion. So I contact to the NS5 lesion and make the design and use the melting curve. And then confirm the positive PCR product. The positive qPCR product use the release the agarose gel and amplification and sequencing, check the blast. So we know that, confirm that which virus is in there. This workflow. This is the workflow. And then the result. In Korea case and in my case, so we have a seasonal. So we collect start in March to October and November. In summer, increase the mosquito. And this time, we have a rainy season. Korea rainy season is too short, but it is too heavy rains every day. And then, so in that time, the mosquito collection is reduced and increased again. and come down. It's annual form. And species composition collection mosquito, we know that. So we have lots of the Craspipians and Aedes vexans. Also, Anopheles species also we collect data. No? Okay. So this one is Craspipians and Aedes vexans nymphoni and Anopheles species mosquitoes. Because in Korea we have 8 species Anopheles, but the 6th species is the Hicarus group. So we cannot, using identification, use the microscope. Just check the molecular identification. So in this data, I use only the microscope used. So I just writing the Anopheles species. And the distribution of major mosquito species is the collection area. Urban and airport, they have the same correct speed plans, but the cattle shed have lots of the Aedes vexans and Anopheles. And then fly virus surveying collection mosquitoes. So I totally collected the 21,000 mosquitoes year. And this mosquito was screening, excluding Anopheles, because Anopheles we just thinking about no have a fly virus. So mosquito were grouped the 785 first, and we detect the 12 first fly virus. So 3 pools of JEV and Chaoyang virus and unclassification the fly virus also 4 pools. So this is a melting cup for the JEV. So summarize this result of this from collection to detection. And so this is the last page. Mosquito surveillance enabled the detection of circulating fly virus in Korea. Mm. They have a lot of the issues in collecting mosquito to detection and we are increasing of this issue. In my case and in my experience, many kinds of students in that project have a grow this mosquito understanding. And so the last page, my meant is like this. Somewhere, something incredible is waiting to be known. Carl Sagan. Okay, thank you.
Okay. Thank you, speaker, for the amazing talk. I think we get a different perspective from Plasmodium to virus. And I can see that we need a lot of effort also in surveillance and in getting more samples. And I guess in the changing world, it's not just about Korea. It's about the whole world because now everything is connected, is one health. So next, I would like to give the floor to ask questions. So anyone in the room or online via Zoom, if you have questions, you can raise your hands. Okay. Yeah, so that.
Okay. Okay, thank you for the chance for me. Actually, I want to ask one big question that's really puzzling me all the time is to Prof. Han, actually. Because after being mesmerized by very colorful 3D structures, actually, I just have a big questions. Is this human adaptations of these parasites actually a rare stochastic event? Or actually is a really fixed, predictable pattern because of these interactions between ligands, infections of parasites? Thank you.
Okay, for the question. Uh, Yes, the genetic malaria actually just nowadays we discovered in the world. There are several reasons. Because of the recently there is development of the fine, very nice, the molecular based diagnostics, like, such as PCR. All right, and more sensitive tool and more accurate tool by qPCR like this. So actually, we don't know this genetic malaria is historically already have in the human, but just we cannot detect or not, or it happened just recently adapted to the human. We cannot conclude that yet, but it seems even the previously, it should have been the human, the monkey by accident, but the by human just we diagnose as a buy-box because all of them looks like buy-box on the microscope. And if we treat by buy-box drug, they can die. But at the moment, we just not thinking about the genetic malaria that is genetic, right? So we need to know exactly from now on what species in the human. Is it from monkey or is it from other human? Uh, so the genetic malaria, once they invade the human, and if they survive in the human and transmit to monkey again or human again, anyway, they will transmit in the community, right? Even their risk is very low, anyway, we have to know exactly because we don't know the risk of the genetic malaria. For example, the Biovax, as we know that the Biovax malaria is not severe, but sometimes the patient die. So is that really Biovax malaria or not adapted well genetic malaria? We don't know. We cannot say anything from that, right? So anyway, once the genetic malaria come into human, they if they survive in human, some any factor by any factor, if they survive, they starting to adapt to human anyway. So meaning that genetic malaria species have a chance to infect human, but of course, we still don't know. Some is not, some is yes. But DBPDRC, that molecular interaction is most essential in non-labellaria clade merozoite invaded human. Even monkey also same. So if we know which residue is most important for the human adaptation, we can targeting only that residue and or we can make a surveillance program to observe the residue. And even in the monkey, if in the monkey have a mutation in the point to well adapt direction to the human, we can make a early warning about the genetic malaria. This merozoite and this species is possibly can infect the human and transmit within the human in the future. We can make that kind of early warning system also. That's why this residue identification is important. And actually, not only DVP and DRC interaction, as I show you, there are lots of RBP proteins and EBP, all of them actually important. But at the beginning, this is very beginning stage. Nobody trying like this. That's why DVP person, we know nowadays knowledge, we know that DVP is most essential. So let's cover that one first. And later we'll move on the RBP proteins and other minor proteins too. After that, we can draw also the how these zoonotic malaria, non-malaria, plasmodium, how they make a evolution. Also, we can draw the map. So that is maybe later big pictures of this study. Yeah, yeah.
So it's really thank you because why I was so thrilled to ask these questions because I'm one of those malaria infection survivor. I'm a survivor actually because once well, back to 7 years ago, it's the first time got blessed by the universe to get my first infection. It was a mixed one. I hope I'm now clear because I moved to Korea because I'm going to bring some very important cases, I'm afraid. So because humans are so really kind of like an enigmatic machines sometimes, and the B5 facts actually because I really mesmerized by this one of species because it's really polite, like a penyair ya uh, in a, in the humans because sometimes it has a great adaptation somehow not to detect by the human immunity system. So somehow it can adjust itself. So, and the other else why I'm really triggered to ask this question because when I see the very colorful grapes, I love the colors because I love the colors because some of the plasmodia still remains in a non-human's host, but the others can cross host. The invasion is can cross into another species. Thank you so much. So let's start with this.
Yeah, thank you. And just everyone. Well, actually, in South America, there has a Plasmodium simium. Actually, historically, we believe that the Plasmodium simium came from the Plasmodium vivax. The human vivax adopted monkey first, and they changed the species as a simium, and the Plasmodium simium also returned back to the human. Yeah, so anyway, the monkey, human, and mosquito and plasmodium all connected each other. So we have to think about all of these natural situations.
Okay, thank you. I think we have a question from online. So, Atika, please.
Okay. Can you hear my voice? Okay.
Agak keras sedikit, maybe a
Can
little.
you hear my voice now?
Yeah, we can hear you.
So thank you very much for the presentation. It's very interesting. I'm sorry I cannot join offline because my my feet is swollen now. So yeah. I have several questions for Dr. Jun Ho Jung. Yeah, because actually my research is about the vector, about the mosquito compared to the parasite. So it's technical question, the first one. In the airport area, like how you put your trap in the airport. I was actually thinking also doing research uh, to collect the mosquito in the airport as well. Because we know that the transmission of the mosquito-borne disease is also related to the human mobility. So that is the first question. Maybe you can answer it first.
Okay, thank you. It's not only airport areas, it's kind of the airport area we call it, but it's the nearby airport areas, far from around 4 or 5 kilometers. So that the airport, airport area.
So it's not in the inside the airport.
Yes, right.
No, it's
Okay.
kilometers or like yeah.
Okay. Thank you. So next question, your finding, like you found GEV in the Culex ppn mosquito, right? We know that Culex trithenorhynchus is a major factor for GEV. So how is in the Korea? Is it like Culex tritenorinus is not the factor for GEV in Korea or only Culex ppns?
In background, I talked that the Curex tritanicus there has the primary vector in Korea for JEB, but some data we show that some Curex ppns and some Curex orientalis, some kind of other species also can detect the JEB. So we call that the primary vector, Curex tritanicus. But other species mosquito can possible to transmission. It's possible. Not only Curex tritanicus. Is the answer?
Yeah. Okay, so how is the GEV cases? Actually, I'm curious, how is the GEV cases in Korea now?
We have not too much, just around 16 cases per year, less than 50.
Yeah, it's low.
It's just keep that numbers.
Okay, thank you. Actually, I have another question for Dr. Jin Hee Han also. Is it okay?
Yeah, sure.
Yeah, actually, I'm more on the vector, so I'm not familiar with the parasites. About the malaria in Korea, so what is the vector for the malaria in Korea now?
Dr. John is expert rather than me.
Oh, really? Okay.
Thank you. We have not too much the primary vector for the anopheles, but we have some secondary vector. Other country they call secondary vector, but we have anopheles sinensis, this, and then anopheles kleine and belene and plus. That is the vector issues for the malaria.
Okay. Another question, like in the study of Jin Hee Han, Dr. Jin Hee Han, like you're using non-Laferranian plasmodium. Why it's not Laferrania?
Yes, because focus on the vivax because vivax malaria exists in Korea, right? So in the vivax class is malaria clade. Unfortunately, in vivax still have a more in vitro culture system. Vivax cannot culture in the lab. There is no in vitro culture system. There is a major drawback to research of the plasmodium vivax. So, in the research in the world, we try to develop the culture system in the lab of the vivax during on the more than 50 years, but all failed. So nowadays, we're trying to make another alternative system to use beside moji, just like citrus species. And luckily, the culture plasmodium nucleoside now is a genetic malaria species in the human blood that we can culture now. So yeah, now just it the opportunity to study about the non-laminaria species of the parasite. That's why I'm also just starting to study about that non-laminaria clade, because also the many species can affect the human, right? But in laminaria clade, the most important plasmodium is only Plasmodium falciparum. Experimentally, other species cannot infect the human. We don't know the reason. But in Rabinaria clay, the plasmodium, the number of species are also huge, and they can affect the human in the future. That is why I want to protect the future risk from the zoonotic malaria. So I'm focused on that, on Rabinaria clay now.
Okay. Thank you so much for the answer.
Yeah.
Okay,
Thank you.
thank you, Atika. So Atika is our lecturer at the Laboratory of Entomology. So I think if you're interested, you can also send email to both of them and continue the discussion there. And I'm really sorry to all the audience because of the time, so we need to close this session. But for those who attend today, then you will still find our guests here until around lunch. So feel free to ask question later. So I think that is all for today, and let's give a big applause again to our guest lecturer. And I will give back the time to our MC.
Okay, thank you so much, Pak Matin, and also thank you for our guest lecturers today. So I think that's conclude our lecture for today's session. Thank you so much for attending this session for the participant both on site or online Zoom. I hope this is can reach your knowledge more about the topic. So thank you for attend and sorry if there are any mistake during the lecture and I will close. Thank you so much. Assalamualaikum. Wassalamualaikum warahmatullahi wabarakatuh.
And continuing this, I think we will have lunch together, and also we will have more discussion as well.
Before we have lunch, we have like a discussion for to have opportunity having collaboration with the near future. Yeah. And yeah, because now I think still here. Because I'm sorry, because our staff rooms already under construction. Yeah, there's only room that can be approved for us today. Yeah. Okay, thank you guys. See you around here.